For number 5, the force due to gravity is 900 newtons, which is g times the mass of the spacecraft times the mass of the Earth all over the distance between them squared. And then we're told that what will be the force on the spacecraft with twice the mass, at a distance from the Earth center is 1/4 as far. So that is what we're looking for. The force is going to be G times 2m times the mass of the Earth all over 1/4 r squared, which is just 2/1/16 times gm mass of the Earth over r squared. So this is 32 times what we had from before, so this thing here. Which is just 32 times 900 newtons. And that gives you 28,800 newtons. Okay, and then the next problem is a vector problem. This takes a little bit more work. So you need to know a few things here to determine the net force on the moon. So number 1, the mass of the moon, 7.34 times 10 to the 22 kilograms. You need to know the mass of the Earth and the mass of the Sun. So the mass of the Earth is 5.98 times 10 to the 24 kilograms. And the mass of the Sun is 1.99 times 10 to the 30 kilograms. Okay, we also need to know the mean distance from the moon to the Earth, which is 3.84 times 10 to the 8 meters. And we need to know the mean distance from the moon to the Sun, which we'll say is the same as the mean distance from the moon to the, from the Earth to the Sun, because they are at right angles. So it's just 1.50 times 10 to the 11 meters. So from that we can say that the force on the moon from the Earth is G times the mass of the Earth times the mass of the moon all over the distance between the moon and the Earth squared. Okay, and when you plug all of that in, you'll get 1.99 times 10 to the 20 newtons. And then we need to know the force on the moon from the Sun, which is just G times the mass of the Sun times the mass of the moon all over the distance between the moon and the Sun squared. And you plug all that in, you get 4.33 times 10 to the 20 newtons. Okay, so then we just have two vectors.
Yeah.
Okay, so now we just need to do a vector addition. So we'll have, look at a picture here. This is 1.99 times 10 to the 20 newtons, and this is 4.33 times 10 to the 20 newtons. And this Okay, so we get something like, here's our 1.99 times 10 to the 20 newtons. Okay, and here's 4.33 times 10 to the 20 newtons. So we have a vector like this at an angle theta. So this is our net force. So the net force is just going to be the square root of FME squared plus FMS squared. And when you plug all that in, you get 4.77 times 10 to the 20 newtons. And then theta is just going to be the inverse tan of FME, so the force between the moon and the earth, over the force of the moon and the sun. When you plug that in, you get 24.7 degrees. So our net force as a vector is 4.77 times 10 to the 20 newtons. And the direction is, we'll say, south 24.7 degrees east. Those don't mean much, but there's the answer.